In this video, we're going to be using Microsoft Excel for making a concentration versus time graph. This is very common for kinetic experiment, especially if you need to get orders of the reaction. You can use it to do average rate, instantaneous rate, or initial rate. So this is a very important skill to master before doing any type of problem. So let's analyze the data that we have here. So in this case, we have the data already in text format. So what I'm going to do, I'm going to open my Excel, copy paste it here. For easy access or view of your data, you can just always zoom it in. I'm going to just zoom it in for a clear view of the data points. Every Excel software or version may have different toolbars. This is a Mac, so this is an old version, I think it's 2011. So get familiarized with your version, and also you can go here to the help and find out any way to insert a scatter graph. So times versus concentration table. What we're going to do is, for this particular graph, we're going to pick the scatter graph. You can use the smooth mark scatter graph if you want to, just to have a better idea of how the trends between the points, right, is. So I'm going to just do that. And if you see, right, we have the graph created. Any graph must have a layout, and that layout can be quickly accessed here. I'm going to just pick the basic layout, which means that I'm going to just do concentration versus time. Okay, I'm going to make sure that my axes are labeled. And then here will be time is given. I'm going to put this, the units is very important, in this case seconds, and then here concentration. Okay. Before concluding, I'm going to explain a little bit of how to change the axis of the graph, especially because you may use this graph later on to calculate instantaneous rate or average rate from the graph. Okay, so here you right-clicked the axis and you go to Format Axis, and pretty much what you can do is to set up the thick marks. Okay, I'm gonna just change that I need to have some thick marks. You have major thicks are the ones that are on the big scale, in this case here. So I'm gonna just enable, right, those if they're already there, and then you have the minor thick marks type, and then I'm gonna put it inside. However, we don't have any scale yet to show you that, so I'm gonna go back here to scale, and then I'm gonna well, you see is there shown, okay, the minor gridness scale. And you can actually divide this by different numbers, but I believe that from here you can just see it very well. And you can just, change this as you please. Okay, you can just enable, let's say that I want to change the minimum to start at 0.02. So like that, I have more precision in the reading. I can do the minor unit instead of 4s by 2, you see? And you have better precision in terms of the reading that you make. So you can do that for Y, or you can just do it for the X value too. So I'm gonna just click here, okay, and I'm gonna just do the same thing, format axis. I'm gonna here, the maximum is 200. Let me see if I put it at 250. I'm gonna change the maximum all the way to 225. Okay, just to have a better idea. I can even do more, 220. You can play around, okay? You can just do this. I want the graph to start at 0. You saw that the scale here was moved. Again, the minor unit, instead of going by 5s, it could be small. I'm going to actually do the major unit going by 25s. and then I'm gonna do the minor unit going by 2s. So let me see what happened if I do that. This is the thing, I haven't enabled the thick mark, so if you do it like inside here and inside here, you're going to be able to see the scale better. So again, using this graph is important in order to calculate activation, to calculate average rate, instantaneous rate, and initial rate. I hope this video helped. Remember to go back to Chemistry in Focus for more video lectures in chemistry.